Hello everyone, my name is Abdul Kamar. I'm a research scientist working at IBM Research AI. I will talk about Boomerang, a proactive insight-based recommendation system for guiding conversational data analysis. This work is done in collaboration with Doris Lee, Isar Kandogan, and Fatma Ozcan. In our growing informational economy, data is at the center of decision making across business organizations, everywhere from retail, construction, entertainment, manufacturing, and healthcare. Having just the data is not enough, as Richard Hamming said in his famous quote. The value of these data driven decisions comes from combining the power of computing with the insights derived from humans. To derive such data driven insights, business users typically hire a small group of highly specialized analysts who have extensive technical experience with data analysis and programming to look for such insights. This high barrier of entry prevents large portions of the workforce from applying the data driven techniques to their domain. One potential solution to the democratization of data science has been through the development of natural language interfaces for data querying. Natural language querying offers an intuitive and accessible interface to interact with data, lowering the barrier required for conducting analysis, thereby unlocking the capabilities of data science for the masses. Existing natural language querying systems allows users to ask questions about their data, and the system interprets the utterances and returns an exact answer to the question. As we can see from these examples, these responses can be in the form of text, tables, or visualizations. Most available natural language conversational interfaces to exploring data are often one directional or user driven, relying on the user to formulate the query. Moreover, they usually restrict the dialogue to fit a fixed set of patterns. These conversation systems might work well for a fixed set of tasks and often provide helpful features such as auto query completion based on schema information. However, they do not provide guidance in terms of useful insights derived from the underlying data that are relevant to the user's current context of data exploration. Without knowing where the interesting insights are, users can miss out on interesting insights that are not on their path of exploration or can be overwhelmed or get stuck during the course of their analysis. To fully embrace the goal of democratization, it is necessary to provide effective and continuous guidance support in the conversation service to allow exploration of data and insight search space in small incremental steps as the conversation with data progresses. We argue for a mixed initiative system where the computer system independently but guided by user responses, analyzes the underlying data given the conversational context, identifies potential interesting and relevant insights from the data, and interjects such insights into the conversation as recommendations to guide the data analysis. The two key challenges in such a system are how to model the conversation context and how to match it to the most relevant, interesting, and timely insights among many in the data. I will now describe the architecture of Boomerang, a conversational recommendation system. Boomerang provides a modular, extensible framework where the individual recommendation modules can be easily integrated to guide conversational data analysis. The key components of Boomerang include a cloud-based conversation service, a business application consisting of a conversation manager, a query generator, and a recommendation manager. The cloud-based conversation service provides support with the user and persists the conversational context across multiple turns of conversation. The conversation manager facilitates the interaction between the conversation service, the query generator, and the recommendation manager. It receives the conversational context representing the user's current state of exploration from the conversation service and triggers the query generator and the recommendation manager to generate a response to the user's natural language utterance. The query generator generates a SQL query against a database to respond to the actual user utterance. The recommendation manager orchestrates a multitude of pluggable recommenders. It is responsible for triggering recommenders to generate insights, updating and storing all insights generated, computing a timeliness score for each insight, aggregating and ranking the insights, and finally, choosing and displaying the top insights based on the user's current state of data exploration. So what makes a good recommendation? The recommendation manager uses a ranking function for recommending useful data insights based on three essential criteria: relevance, interestingness, and timeliness. I will now describe each of these in further detail. We first look at what insights are considered interesting to recommend to the user. Interestingness captures the extent to which the selected insights actually show something interesting about the underlying data based on statistics computed by each individual recommender. Each recommender computes an interestingness score in terms of different statistical properties computed from the underlying data. In our prototype, we have implemented 6 different recommenders that find interesting statistical patterns in data. These include deviation, correlation, outliers, skewness, variance, and kurtosis. These interestingness scores are based on well-established metrics used for data mining and have been used extensively in existing visualization systems. Providing interesting statistical insights to the user helps them to understand their data better and could assist users in choosing appropriate features for downstream machine learning tasks such as prediction of profit margins based on correlation between features involving sales and inventory levels. Now, on to the second part of what makes the recommendation a good recommendation. We look at why relevance is important. Relevance measures how relevant the selected insights are to the user's current state of data exploration as captured by the conversational context. So here, the user says that they are interested in learning about sales. We can see an example of a very relevant response on the left since the recommended insight involves sales. Compare this to the less relevant response on the right where the insights are recommended have nothing to do with sales. Now, the relevance of an insight extends beyond just whether an attribute is mentioned or not. Given a series of user utterances in the conversational context captures the user's state of data exploration. As shown in these examples, the context contains key parts of the conversation, such as which attributes or aggregation function is involved, or what task the user is engaged in. In practice, this is extracted through the entities and intents detected in the conversation service. The relevance score is therefore a measure of how closely the user's context matches with each of these insights. In our current implementation, we use 6 different statistical recommenders, but each insight is represented as a vector of features. The conversational context that captures the user's current state of data exploration is also represented as a vector of features. The similarity between the two vectors is computed using a vector space model that captures the relevance of insights to the conversational context. To apply the vector space model, we first convert the categorical values in the context and insight JSON representation as shown in this slide into binarized vectors via one-hot encoding. Now, having these vectors is not enough. Our converted vectors are not aligned in the sense that the term 1 in our context vectors refers to something very different than the term 1 in the insight vector. We develop a vector alignment procedure which maps the context and insight vectors into the same vocabulary. We identify the terms that are equal and place them in the same slot. Now for the terms that are different in the context and insight space, we create a dictionary mapping that specifies how the terms in the context and insights relate to each other. For example, here, we indicate that the system should display insights that are easy to understand when the user's context is at an early stage of exploration. These mappings are specified by domain experts. Our system accounts for both one-to-one and one-to-many mappings by automatically aligning these terms into these derived slots. A vector-based representation also allows the use of word, sentence, or graph embeddings pre-trained or fine-tuned for data exploration conversations to represent the semantics and structure of insights and context. This facilitates comparison using different similarity metrics and learning the appropriate weights in the context of conversation. In the current implementation, we use cosine similarity to compute relevance given the aligned vector-based representation of context and insights. Now moving on to the last part of what determines a good insight to recommend to users in conversational data analysis, we look at the effect of timeliness of an insight. To sustain a meaningful conversation, the system must show useful insights at appropriate turns in the conversation. This means that we cannot simply keep showing users the same insights at every round, even if the insight scores very highly in terms of interestingness and relevance. To downweigh certain highly frequent insights, we compute a timeliness term based on the frequency that the insight is shown across the utterances. If the frequency is high, then the value of timeliness is low. If the frequency is low, then the value of timeliness, which means that the insight is very timely and rarely occurring, so we want to prioritize that. Now to recap, we know that interestingness is measured by statistical trends and patterns that is coming from the data itself, whereas from the user's perspective, relevance is a measure of how closely the insights match with what the users have been talking about. A timeliness is a way of ensuring that we are showing the most up-to-date insights throughout the conversation. Given that we have a score for interestingness, relevance, and timeliness, we combine all of these into a weighted cost function that determines how useful this particular insight is to the user at a particular point in conversation. These weights could also be adjusted depending on the current state of exploration. For example, if you are in an early stage of data exploration, we could prioritize interestingness over relevance using different weights. The recommender finally picks the top K insights as recommendations to be provided to users through the conversational interface. The value of K is a parameter that is provided to the system as input and may be determined by a combination of several factors, including the screen real estate available to the recommender application and the desired cognitive load. We recommend the users to see the demo video to see the prototype implementation of Boomerang in action. In summary, I hope I have convinced you of the importance and value of providing guidance and recommendation throughout the conversational data exploration. The focus of this work has been on developing a computational architecture and framework for recommending relevant interesting and timely insights. Boomerang combines all of these into uh, a combined metric that ranks the insights and recommends the insights based on the current conversational context of the user. Thank you. Next, I'll walk you through a demo of our prototype implementation of Boomerang. Hello, everyone. This demonstration shows a typical interaction of a user with Boomerang, a proactive insight-based recommendation system for conversational data analysis. The user here explores a sales dataset consisting of information about sales and profit margins of different products, retailers, order details placed by customers, and inventory levels. The user interface consists of two panes. The pane on the left shows the conversational interaction with the user, and the pane on the right shows the recommendations provided by the system at each step of the conversational data exploration. We highlight the use case of a non-technical business user exploring a new dataset with the goal of extracting useful insights and identifying interesting data properties to make better business decisions. The user starts with asking the system to show some interesting facts about the dataset. In response, the system provides some insights from the underlying dataset, such as the existence of a strong correlation between unit sales and unit cost. Note that each insight shown here has three scores associated with it: relevance, interestingness, and timeliness, each of which have been explained in detail in the paper. We see that the insights shown at this early stage of data exploration have a high interestingness score. Having seen the recommendations given by the system, the user now expresses interest in sales. The system responds to the user query with an actual chart showing the count of sales records binned by the sales total. In addition, in the right pane, the system provides an updated set of insights relevant to the sales, such as charts showing a strong correlation between gross profit and sales total. Based on the system's response to the user asks a follow-up question requesting for the top 5 organizations with the highest sales. Again, the system responds with an actual answer to the analysis query in the form of a table and a set of recommendations in the right pane relevant to the current query. Next, the user asks if there is any correlation between the sales and profit. The system responds to the user query saying there is a strong positive correlation between sales total and gross profit with a Pearson's correlation coefficient value of 0.96. It also shows relevant insights that show the variation of the sales total with gross profit and other related insights such as the correlation of sales price with unit price. Next, the user asks about the sum of margin. The system interprets the user's intent and provides the value of the sum of gross margin as well as recommends insights about the variation of gross margin by promotion types and order methods. As you can see, the value of relevance metric of these insights varies according to their closeness to the current state of data exploration captured via the conversational context. Finally, based on the system's recommendation, the user asks a question on sales by promotion type, to which the system responds with a chart showing the variation of sales total with the promotion key and also provides other relevant recommendations on the right pane. This concludes our demonstration on Boomerang.